Hello students, now we will have a brief introduction of the subject transmission lines and RF. What is this transmission lines and RF exactly speaking about? Actually, it is a continuation concept of your analysis of electromagnetics. What is electromagnetics? Electromagnetic fields, already we have come across. So from the fundamental analysis, how it has been modified as intuitive parameter. Already this we have seen in electromagnetics. Likewise, in transmission line, what is the fundamental parameter? How it will be defined as an intuitive parameter. As we know in electromagnetics, it is mu, epsilon and sigma defining permeability, permittivity and conductivity. Same way, intrinsic impedance, attenuation constant, phase constant and tan del, the skin depth del representation. Okay. Now in transmission lines, the primary constants are resistance, inductance, capacitance and conductance. G is conductance. So transmission lines, same analysis from intuitive point of view. It is characteristic impedance, alpha the attenuation constant, beta the phase constant and the voltage standing wave ratio. Now we'll have the different types of transmission lines based on either AC or DC. It is first classified. And then the AC transmission lines are further classified into short transmission line, medium transmission line and long transmission line, in which medium transmission line can have either bimodal or T-model. Network, you know, a network can either take up the English shape T or pi. So based on distance is the classification of the transmission line. Based on material and shape, this is what is very important for us. It can be either acting in homogeneous medium or inhomogeneous medium. If it is same, if it is not the same, whether it is single-ended or differential-ended, so it can be coaxial or strip line, whereas in inhomogeneous it is microstrip line, coplanar. Same way it is baric parallel plate in terms of differential, shielded pair. Everything is a transmission line only, but depending on the shape material it is classified into different types. So now our basic definition says that they are nothing but high frequency electrical cables which is composed of two or more metal wires. Actually in your fourth unit you'll learn about the waveguides. From a two wire, why it is modified into a single conductor. If there are two different wires, what has got to be the negative? Why we are moving for a waveguide section. So TEM wave, transverse electric magnetic mode, transverse electromagnetic mode. So in this diagram, between the transmitter and the receiver, a generator and the load, a coaxial line is implemented, in which case you have the representation of the cross section, a representation of E field and H field. E field here is radial, whereas H field is azimuthal. As you see the lines very clearly, red is E, which is radial, and H is azimuthal. So the propagation is into the phase. This we have already seen in electromagnetic fields. Now we'll see what are the various types of TEM modes. As I told you, when the electric and the magnetic fields are perpendicular to each other and both are also orthogonal to the direction of propagation. So different TEMs, how the coaxial line TEM is passing through for a two-wire line, for a parallel plate line, coplanar waveguide, microstrip line. As I told you already, there are different types of transmission lines. From the transmission line, we are going to go into the waveguide section. It can either be a rectangular waveguide section, circular waveguide section, a coplanar analysis. Other than that, the recent trend speaks about the optical fiber. So in all cases, how the transmission line is being modified. This is what is our subject exactly speaking about. So what is a transmission line exactly? The transmission line is connected between the generator and the receiver, or the source and the load. As we see from the diagram, this is called as a sending end and this is the receiving end. To directly view as a diagram, not seeing into the looking into the, this is a representation, general representation, but this gives you the clear idea of how this transmission line is happening. So you can imagine yourself that the transmission lines consist of millions of little circuit elements and they are distributed along the overall length of the line. This is the overall length of the line. So these are not discrete, but they are continuous along the length of the transmission line. So when do we say that it is along the length of the line? Now you imagine the transmission line parameters. As I told you, the parameters are R, L, G and C. So you have your representation of del cell. This model is made accurate when in this equivalent circuit we are assuming del Z to be approaching towards 0. I told it is continuous. All elements are continuous. You can see the difference between previous diagram and this diagram. A general look, two parallel lines. But when it is coming into the descriptive section, you have the continuous elements in between, separated by an element of decel. It is depending on the analysis of comparison of wavelength of the signal. So we are assuming that it is del z approaching towards 0, a very infinitesimal value. So all parameters RLGC are defined in terms of del z. So RLGC circuit model is a basic representation where R defines the resistance per unit length, and this is due to the resistivity of the conductors, whereas inductance is defined in terms of the energy stored in the magnetic field. Whereas G is the conductance, it is not equal to 1 by R. This and this are not inverse case. This is very, very important. Rather, it is conductance per unit length. And C, the capacitance per unit length, which is due to the stored electrical energy between the conductors. As we know, capacitor stores electrical energy and inductor stores magnetic energy. This is what is a representation of the circuit model. So a lumped element circuit model, how this is a transmission line, this is a sending end, this is a receiving end, there is a voltage, there is a current. So V of Z and I of Z, how to define it in terms of R, L, C and G. This is what is a basic equivalent circuit of the lumped element. The circuit model has been modified from circuit theory into field theory and the transmission line theory. So this is how the transmission lines are exactly applied into. Now we'll have an idea about what is RF analysis speaking about. To speak about RF, you should know the basic types of electricity, either direct current or the alternating current. As you know, direct current is battery and alternating current is the power in our house. But alternating current has the frequency. So if you say in India it is 50 Hz, 50 cycles per second. If it is in US, it is 60 Hz, 60 cycles per second. From this, direct current is moving from direct current to alternating current. From the alternating current, we are moving into the RF. So how the RF or the radio frequency, whatever is defined, it is not strictly defined, but it can vary from 20 gigahertz to 300 gigahertz. 20 kilohertz, it is 10 power 3, giga is 10 power 9. They can also be conducted through either cables or conductors. In electromagnetic fields, we have seen this. They can travel through space, so the electric field and magnetic field are perpendicular to each other. What are the RF applications? Transfer the information or sense, detect objects, heat objects. In transfer information, it is used in radio, broadcast television, cable TV, Wi-Fi, etc. Likewise, sensing in radar, body scanners, material measurement. Heating, a well-known application, microwave oven, industrial application and medical application. But the RF range is defined in terms of specific cases. It is depending on the application, the frequency range. So they are lower frequencies generally speaking, but they can propagate longer distances and penetrate objects better. For example, when we broadcast AM and FM, it has to penetrate a long way, penetrating the buildings even. But we don't want the Wi-Fi, which is in the range of 2.45 gigahertz, to move too far. So in most of the places, it is set to general frequency set by the government or some regulatory agency. So we will also measure this RF measurement using a network analyzer. We'll have a brief idea of this network analyzer. This is in laboratory, this is in the workplace, in industry. How this is addition of a signal generator along with a spectrum analyzer. How this analysis is being made is learnt using the network analyzer, whether it is scalar network analyzer or a vector network analyzer. So this gives the introduction of the subject what we are exactly proceeding through. Thank you students. We will see in the continuation concept.